In this exercise, we will find the linear velocity of the tip of a windmill blade. In order to do that, we need the angular velocity of the blade. The angular velocity is given by the following. We'll take our 25 revolutions per minute. We'll multiply by a conversion factor. We know there are 2 pi radians per revolution. So our units of revolution will now cancel, and we will be left with the proper units for angular velocity, radians per minute. This gives us 50 pi radians per minute. Now that we have the angular velocity, we can use the formula that connects linear velocity to angular velocity, namely v equals omega r. We just need to multiply the angular velocity by the radius to get linear velocity. So notice that as the radius, the distance from the axis of rotation, increases, the linear velocity increases. So in other words, the further we are from the axis of rotation, the larger the linear velocity will be. In this particular case, the linear velocity is 50 pi radians per minute multiplied by the radius, which is 50 feet. So that's the distance from the axis of rotation. This then gives us 250 pi feet per minute. And that is our linear velocity. There is a little bit of a subtlety here. Angles that are measured in radians are unitless. So we put the RAD as the unit primarily to indicate that the angle is not measured in degrees. When we're doing a computation, if it makes sense, we can leave the radian unit off. Again, because an angle measured in radians is truly unitless. So when we are coming up with our units for linear velocity, we know that the units of linear velocity should be distance per time. So it makes sense in this case to leave off the RAD and ignore it. I hope that makes sense.